So it has been told to us side AB is parallel to side CD. So let's put arrowheads, and AD equals BC. Put a bar. Diagonals bisect, rather, they haven't said bisect, they have said diagonals of the quadrilateral ABCD intersect, all right, at P, and AP is equal to PC, all right. ADX, that's the green color, longer line is a straight line, and D is the midpoint of AX. So if D is the midpoint of this long green line, what can we say about AD and DX? They should be equal because D is acting as the midpoint. So for D X, what would I put? 1 bar, because I have put 1 bar for AD. All right. Prove that the area of the quadrilateral DBCX is twice as the area of the triangle ABC. All right. What's the strategy? What's the plan? Okay, I got a plan. Let's take the pencil and put the plan. Plan is this. Now, if you look at the quadrilateral DBCX, the one I'm coloring in pink now, and quadrilateral ABCD, do they share a common side? Let's see what do I mean by ABCD, this blue color quadrilateral. Do they have a side in common? Yep. What is it? It's BC. All right. So then, if I prove that this blue color quadrilateral is a parallelogram, and this pink color quadrilateral is also a parallelogram, these two blue and pink shapes become parallelograms with the same base. And not only that, if I'm able to prove that this blue color quadrilateral is a parallelogram, and also this pink color quadrilateral is a parallelogram, I can also say that both of these shapes, or both the parallelograms, are between the same pair of parallel sides. That's BC, or same pair of parallel lines, that is BC and AX. See, BC is the floor, the ground, and AX is the roof for both the shapes. So why am I trying to prove that these two are parallelograms with the same base and between the same pair of parallel lines? If I prove it in that way, I can then say the areas of the two shapes should be equal. Why? Because there's a theorem which says parallelograms with the same base and between the same pair of parallel lines are equal in area. All right. So what's the first thing I'm trying to do? I'm trying to prove this blue color shape, that's ABCD, is a parallelogram. And then I should try to prove the pink color shape, that's DBCX, is a parallelogram. Now, why am I trying to prove? And once I prove these two are parallelograms, I can say their areas are equal. But why? Why would I do that? Because I see that triangle ABC is inside the quadrilateral ABCD, that is inside the blue color quadrilateral. And what's AC? It's a diagonal. So when it comes to a parallelogram, a diagonal breaks the area of the parallelogram into two equal parts, which means the, the area of ABCD would be twice of triangle ABC if ABCD is a parallelogram. Understood? So, if ABCD is twice of triangle ABCD, uh, if ABCD is twice of triangle ABC's area, then DBCX2 should be twice of triangle ABC's area. All right? So hope the plan is clear. All right? So let's execute the plan. Let's see whether it works. So what's the first thing I'm trying to do? Prove that ABCD is a parallelogram. Let's check whether we can do that. With the given data, can we directly say it's a parallelogram? There's one pair of parallel sides and one pair of equal sides. No, because uh, how do we prove a given quadrilateral is a parallelogram? There are multiple ways to prove. One way is if we prove that one pair of opposite sides are parallel and equal, then that quadrilateral becomes a parallelogram. Shall we check whether we can prove in that way? Or is there's a second way to prove? What is it? If both pairs of opposite sides are parallel, then that quadrilateral becomes a parallelogram. Or is third condition that if both pairs of opposite sides are equal, then too that quadrilateral becomes a parallelogram. Or as we can also use if opposite angles are equal. If both pairs of opposite angles are equal, then it's a parallelogram. Or as if diagonals bisect each, if we prove that diagonals bisect each other, then too it's a parallelogram. So there are multiple ways to prove a given quadrilateral is a parallelogram. All right, let's see which method can we use. So we know these two angles. If this is y, this has to be y. Why is that? Because they are vertically opposite angles. All right. And we also can say if this is, let's put a letter like if this is T, this has to be T. Why is that? Because alternate angles. We have been told the up line is parallel to the bottom line. So then if the lines are parallel, alternate angles or Z-shaped angles, they're equal. All right. So I feel that we can prove triangle APB is congruent to triangle CBD. These two triangles, what I'm marking with a circle and a tick. So if we prove this top triangle is congruent to this bottom triangle in which I have marked a tick, then we can say AB is equal to CD. Then we can prove ABCD is a parallelogram. All right. So let's say the two names of the two triangles. In triangle, what's the top triangle's name? APP. And what's the bottom triangle's name? CDP. Triangle CDP. What can we say? We know AP equals PC. AP is equal to CP. How is that? Because that's data. They have said, see, they have said AP equals BC. So it's given or data. You can say given or you can say data. In brackets, you write the reason for each statement you write. Okay. And we also know we have marked Y and Y. What is it? Vertical opposite angles. So angle APB is equal to angle CBD. What's the reason? Vertically opposite angles. So what's the plan now? How am I going to prove the two triangles are congruent? Under what condition? I have two equal angles and one equal side. So what am I going to use? AAS. So I have a S, I have an A. Let's look for another A. Yes, there is. I have marked as T. So what is it? What's that angle? BAP. Angle BAP is equal to angle DCP. Within brackets, you got to write the reason why I was saying so. How do you know they are equal? You can write the longer reason. What is it? When the lines are parallel, alternate angles are equal. Or as you can say AB parallel to CD and BAP and DCP are alternate angles. You can write the reason in this way too. So what you got to communicate to the one who's marking the paper is that you know that when the lines are parallel, alternate angles are equal. All right, so we have two angles in a side. So let's check whether we can use, we can say these two triangles are congruent. So we have two angles, but we got to look for the side. So where are the equal sides? In the top triangle, where is the equal side? That's front of the angle that is not marked. There's no, that's empty. I haven't put any letter. Look at the bottom triangle, the equal side, the side with two bars, that is front of the empty angle, which means AP and PC are the corresponding sides. Why? Their location is the same. Both of those are front of the front of the angle which we haven't marked anything. Got it? So which means we can say triangle APP is congruent to triangle CDP. And within brackets, what does these three lines mean? Congruent was a real symbol for congruency. It should be not three lines, a wavered line and equal sign. But you don't have to write in that way. You can simply put three lines, doesn't matter. It's all right. So now within brackets, you would write the condition that's angle, side. All right. So now we have proven that triangle ABP is congruent to triangle CDP. The up triangle, let me uh, color it and show you. That's this triangle is congruent to this blue color triangle. All right. So if triangles are congruent, their corresponding sides are equal. So then what can we say? So we can say CD and AB. Where is CD? Look where CD is, front of angle Y, and where is AB? Front of angle Y. So what can we say about CD and AB? They are AB and CD are corresponding sides. Corresponding sides means the sides in the same location of the congruent triangles. So AB and CD are corresponding sides of congruent triangles. Therefore, AB equals CD. All right. So now we have proven that AB is equal to CD. So now what's the next statement we can make? Now we can say in quadrilateral, in quadrilateral ABCD, AB parallel to CD. AB is parallel to CD. Who said that? The one who gave the question to us told it. So it's given a semicolon here. And AB equals CD. Who said that? That we found out. So proved above. We have proved, we have proven it above. So proved above. Here we have proved it. So you can say within brackets proved above. So therefore, ABCD is a parallelogram. Why? Because in a quadrilateral, if one pair of opposite sides is parallel and equal, then that quadrilateral should be called as a parallelogram. Got it? All right, let's go further. All right, so now we have proved ABCD is a parallelogram. So let's mark the things related to parallelogram in ABCD now. Let me use a different color pen to mark the things that I'm adding. So I have got to know ABCD is a parallelogram, which means AB equals CD. Let's put 3 bars and 3 bars. And AD should be parallel to BC. If it's a parallelogram, opposite sides are parallel. All right. So looks like our plan is working well. What's the next thing I'm trying to do? I'm trying to prove that BCXD, that is this pink color pink color parallelogram, or rather, sorry, pink color quadrilateral. I'm trying to prove that this pink color quadrilateral is a parallelogram. Let's see whether I can do it. I feel like it's going to be easy because, see, we know since ABCD is a parallelogram, AD is parallel to BC. But we have been also told ADX is one straight line. So if it's a straight line, definitely BX also gets 3 arrows. Why? It's a straight line. So if AD is parallel to BC, definitely this entire line AX is parallel to BC. All right. So let's use that. And we already know that dx is equal to bc. Look at the diagram. There's a bar, and one bar. All right. So then how can we prove dbcx is a parallelogram? That's going to be one pair of equal and parallel opposite sides. All right. So that's the strategy. Let's execute it. So what's the first thing we say? We say dx. First we say AD is parallel to BC. They'll ask why? Why are you saying so? So let's say the reason. Because ABCD is a parallelogram. We have already proven it. ABCD is a parallelogram. All right. But that's not what we wanted. We want to say that DX is parallel to BC. All right. So then we can say ADX is a straight line. Who said it's a straight line? The one who gave the question has told us ADX is a straight line. Therefore, or then, what can we say? DX should be parallel to BC. All right. So we can put two arrows here too. And what's the other thing we can say? Dx is equal to BC. Now, how did we put one bar here? Because we were told D is the midpoint of AX. All right. So what do we write? First we write AD is equal to DX. How? Within brackets. What is the reason? Why did we put one bar for AD and one bar for DX? Because we were told D is the midpoint of AX. But that's not what we want. We want to say that dx is equal to bc. AD equals dx. Then we also know AD is equal to what? BC. Who said AD is equal to BC? There are two ways to say. They gave you in the paragraph they have given to you that AD is equal to BC, or is AD is equal to BC because they are opposite sides of a parallelogram. So you can write whatever the reason, since they gave us at the beginning as a given. Then what can I say about dx and bc? AD is equal to dx and AD is equal to bc, then dx equals bc because both dx and bc are equal to AD. Then dx should be equal to bc. All right? Right. So it was initially marked, so there's nothing to mark now. But the only thing, I put one bar here. Can you see one bar here and one bar here? I put that initially, but now what I did was I told my examiner or the one who marks, how do I know that dx is equal to bc? All right. All right. So now we can say in quadrilateral BCXD number one, dx parallel BC, and number two, dx equals BC. So therefore, this quadrilateral BCXD gets a special name. What is it? You don't have to call him you don't have to call him a quadrilateral anymore because he gets a special qualification now. What's the qualification? He becomes a parallelogram. Why? Because if a quadrilateral has one pair of one pair of equal and parallel opposite sides, then it becomes a parallelogram. So therefore, BCXD is a parallelogram. All right. So now we have proven ABCD is a parallelogram and BCXD is a parallelogram. So then what's next? We got to tell our marker that we know that both of them are going to have the same area. All right. So how do we show that? All right. So now what's next? Let's say to our marker that we identified that both of these parallelograms are having the same base. So let's say that. What is it? Parallelogram ABCD and parallelogram BCXD. See, both of them have BC. That means they have a common base. So parallelogram ABCD and parallelogram BCXD are having the same base. What's the same base they got? Both of them are standing on what? BC. So same base BC. That's like the flow. So both of them have the same ground, and parallelogram ABCD and parallelogram BCXD are having the same base BC, and they are between the same pair of parallel lines. Between the same pair of parallel lines. What's the pair? Look at these. Look at both the parallelograms. Let's color to identify. The top one, let me color in green. So green one is between what two parallel sides? If BC is the base, where is the roof? The roof is AD. Or we also can say this green parallelogram is between the parallel line BC and AX. And look at this parallelogram, what I'm coloring now. What's the ground? BC. And what's the roof? Again, AX. So which means both of them are between the same pair of parallel lines, BC and AX. So between same pair of parallel lines, the green color line BC, this BC down here, and X. Therefore, so if two parallelograms are in such a way, we can say their areas are equal. Therefore, area of parallelogram ABCD is equal to area of parallelogram BCXD. Now, let's check whether our examiner is happy with what we have proved. Let's see what is his requirement is. All right, so let's see what's the requirement. Prove that area of the quadrilateral DBCX. All right, so DBCX and BCXT, same thing written two different ways. All right, just the change in the way the letters are written. So prove that the area of the quadrilateral DBCX is twice the area of triangle ABC. Uh-oh, problem. Because we have proven area of BCXT is equal to area of another parallelogram. But here they want us to show the connection between DBCX and another triangle. So how can we bring a triangle into the picture? Let's see how to do it. One thing we could do is, where is triangle ABC? ABC. So it is part of what? It is inside the triangle AB. It is inside the parallelogram ABCD. So we can say area of parallelogram ABCD. So ABCD has two triangles, right? What is it? That's ABC, this one. That's triangle ABC plus triangle, this one. What am I coloring now? That's triangle ACD. So the parallelogram ABCD can be made or is formed or has been splitted into two triangles. That is triangle ABC plus the triangle ACD, the blue one. So let's write it. Area of parallelogram ABCD equals triangle ABC plus triangle ACD. The area of parallelogram ABCD. Now remember, we don't want, see what we want is twice the area of triangle ABC. So shall we check whether we can get 2 times of ABC? How can we get it? All right. See, what's AC? It's a diagonal. So all of you got to know, in a parallelogram, diagonal bisects the area. What does that mean? If this black triangle is 70 square centimeters area, this blue triangle also will have the same area, 70. Diagonal cuts the parallelogram into two equal triangles. Got it? So what can we say then? Area of parallelogram ABCD is equal to what? Area of triangle ABC plus, we can replace ACD with what? Something equal to it. What is ACD's area equal to? This blue triangle's area? It is equal to the triangle in the other side of the diagonal. What is it? Triangle ABC. Now your examiner would ask, hey, what happened to ACD? Why did you replace ACD with ABC? So you got to tell to your examiner that you know that triangle ACD equals triangle ABC. I'm not writing the word area. You got to write the word area. You can just say AR, area, okay, of triangle ABC, comma. The reason for that, in a parallelogram, in a parallelogram diagonal bisects the area. So the entire parallelogram's area is cut into two pieces or two equal pieces by the diagonal. So then area of parallelogram ABCD is equal to what? Area of, you can say plus, when you add triangle ABC with triangle ABC, what do you get? You get two triangle ABCs. So two times area of triangle ABC. All right, now let's check whether the examiner is happy. Prove that the area of quadrilateral DBCX. Oh, we have proven that ABCD's area is twice of ABC. But they want us to prove DBCX's area is twice of ABC. No worries, we know, we have already said, what is it? We have said area of ABCD and area of BCXD or DBCX, both the same. So what can we do? We can replace the left-hand side. So area of parallelogram, no need to write ABCD. Why? We have said ABCD is equal to what? DBCX. So BCXD and DBCX mean the same, all right? So area of D, parallelogram DBCX equals 2 times area of triangle ABC. All right. So even if you feel like your examiner would ask you, how did suddenly ABCD become DBCX? You can write the reason within brackets. All right. So let's see what's the reason you would write. All right. So then what's the reason we can write for this one? If they ask you, how did ABCD get replaced with DBCX? You can simply say area of ABCD equals area of parallelogram ABCD is equal to area of parallelogram DBCX and put a comma. And you don't have to write the reason again. Why? It's already proven. See, we proved here, right? So proved above. You can simply say to your examiner that you have proved this fact in your above workings. All right, so this is what they ask you to prove. Now remember, this is not the only approach or this is not the only strategy to do this proof. There are multiple ways, but I felt using the theorem of uh, parallelograms on the same base and between the same pair of parallel lines is going to be useful for this one, and it's good to remember as a revision too. So that's why I took the approach what I took. But there are other approaches too. All right. Okay. That's it with this question.